Hello, my dear students. This is Amanpreet Kaur, and today we are going to start with the second video of class plus 2 mathematics, and the chapter we are doing is applications of derivative. In the last video, I have explained you what are the uses of applications of derivatives, where we are using it, and what are their real life applications. So today we are going to start with exercise 6.1. In 6.1, question number 1 and 2 are exactly like we have done the examples. So I will be starting with the question number 3. If you see question number 3, the radius of circle is increasing uniformly. So radius is increasing at the rate of 3 centimeter per second. Find the rate at which the area of the circle is increasing when the radius is 10 centimeter. So in this question, if you see, the radius of the circle is increasing with 3 centimeter and we have to find the increase in area of the circle. So what we will be doing is, let at any instant of time t, the radius of the circle be r and area of the circle is pi r square. So now dA by dt, we have to find this. So how we come to know that? We have to differentiate it with respect to time. If you clearly see the units, the radius is increasing uniformly at the rate of 3 centimeter per second. So per second means it is according to time. So we have to find the area of circle. So with respect to time. So now we will differentiate area. We will get 2 pi r and dr by dt is 2 pi into, we will put that is 10, and we will get the answer is equals to 16 pi centimeter square plus per second. So mind it, you have to write the units also, because unit of area is centimeter square and we are differentiating it with respect to time. So centimeter square per second. This is your question number 3. Now moving to question number 4. An edge of a variable cube is increasing at the rate of 3 centimeter per second. So edge means a side. Let x be the edge of the cube and v be its volume. Now edge is increasing at the rate of 3 centimeter per second. So it means what is given to us? dx by dt is given to us, right? So now how fast is the volume of the cube increasing when the edge is 10 centimeter long? We have to find dv by dt. We have to find. So dv by dt can be written as dv by dx into dx by dt. This is according to chain rule. What is dv by dx now? As v is equals to x cube, so dv by dx is equals to 3x square. And what is dx by dt? This is given to us. That is, we know that in the question the edge of the variable is increasing at the rate of 3 centimeter per second. So it is given 3. So it becomes 9x square, right? And what we have to find? Volume of the cube increasing at 10 centimeter. So we will put x is equals to 10. 9 into 10 square is 100. So it will become 900. So what you have to see? You have to see the demand of the question, what is asked. So what will be the unit? As we know that it is 900 and volume is centimeter cube per second. We are dv by dt we are finding. So centimeter cube per second. So answer is 900 centimeter cube per second. So I hope this is clear to you now. So now moving with the question number 5. If you see a question number 5, this is exactly like example number 3. A stone is dropped into a quiet lake and waves move in circle at the speed of 5 centimeter per second. Now when the stone is dropped in a quiet lake, suppose this is the lake, and when you throw a stone you will get the circles like this, waves in the form of circles, right? So in which the radius is increasing considerably. Now at the instant when the radius of the circular wave is 8 centimeter, suppose at this time the radius of the circle is 8 centimeter, how fast is the enclosed area increasing? So we have to find the increase in area with respect to time, because it's given that a stone is dropped into a quiet lake and waves moves in circle at the speed of 5 centimeter per second. So what it is given? It is given dr by dt, unit dr by dt, that is equals to 5 centimeter per second. So centimeter is the unit of radius, per second means differentiating with respect to time. So dr by dt is given and we have to find dA by dt. So how we will find dA by dt? dA by dt is equals to dA by dr into dr by dt. This is again chain rule. And what is dA by dr? We know that area of the circle is pi r square. So dA by dr is 2 pi r, differentiating with respect to r, and dr by dt is given to us as 5. So it will become 10 pi r. And we have to find dA by dt when at an instant radius is 8 centimeter. It means r is equals to 8. So putting the value 8 here, we will get 80 pi, right? So unit will be centimeter square per second. This is the increase in area at an instant when radius is 8 centimeter. I hope this is all clear to you. Number 8. A balloon which always remains spherical on inflation is being inflated by pumping in 900 cubic centimeter of gas per second. So if you see the 900 cubic centimeter of gas per second, so what it is? Cubic centimeter is the unit of volume and per second is time. So it means we are given dV by dt. So according to the question, dV by dt is given to us as 900. I hope this concept is clear, everyone. Now second is, find the rate in which the radius of the balloon increases. We have to find the rate in which radius of the balloon increases. That means we have to find dr by dt when the radius is 15 centimeter. So dr by dt we have to find at r is equals to 15 centimeter. So this is our question. Let us see the figure. Which type of figure it is? A balloon. So balloon is which type of figure? This is spherical, right? So balloon is spherical in shape. And what is the volume of sphere? We have done in class 9th, we have done in class 10th. The volume of the sphere is 4 by 3 pi r cube. Now let us see the answer of this. At any instant of time t, the radius of the balloon is r and the volume be v. Volume is 4 by 3 pi r cube. We are given dV by dt. Let us differentiate it. dV by dt is equals to dV by dr into dr by dt. Right? So let us find dV by dr. By using this formula, we will get 4 pi r square. dV by dr is equals to 4 pi r square, right? And next is dr by dt. This is clear, everyone. So this value is given to us. This value is equals to 900. So we will put the value, we will get it as 900. From here we will find dr by dt. So whatever dr by dt, and we'll fill the value of r is equals to 15, we will get the answer, that is rate of increase of the radius of the balloon. This is our question number 8. I hope it is clear, everyone. Moving with question number 9 now. A balloon which always remains spherical has a variable radius. So what is given to us? Variable radius is given to a balloon which is a sphere. So it means again we are given the volume which is spherical in shape. So volume of the spherical shape is 4 by 3 pi r cube. Find the rate in which its volume is increasing. Now we have to find dV by dt when the radius is 10 centimeter. It means we have to find dV by dr. Why dr now this time? dV by dr we have to find. It is not given anywhere that you have to find the rate at some seconds. So only a unit is given. Variable radius is there, right? So with respect to radius we are going to differentiate volume because variable radius is there. So let us see its answer now. at any instant of time the radius of the balloon be r and volume is v. We know that volume is 4 by 3 pi r cube. We will find dv by dr because it is the radius which is variable. So when we will differentiate it, we will find its answer is 4 pi r square, and putting the value of r as 10 centimeter, we will get it is equals to 400 pi centimeter square. This is rate of increase of volume with respect to change in radius. I hope everyone this is clear to you now. Moving with question number 10, very important question. In question number 10, if you see a ladder 5 meter long is leaning against a wall. There is a ladder 5 meter long. Bottom of the ladder is pulled along the ground away from the wall at the rate of 2 centimeter per second. How fast is its height on the wall decreasing? Now what we have to find, how fast is the height on the wall decreasing when the foot of the ladder is 4 meter away from the wall. Now let us see this answer. In this question, what is given to us, if the foot of the ladder, let us take another solution also. So in this question, see the figure here, a ladder is 5 meter away, right? And next is the bottom of the ladder is pulled along the ground. This bottom of the ladder is pulled along the ground away from the wall. This arrow is indicating that the foot of the ladder is moving away from the wall at the rate of 2 centimeter per second. Here time is given to us per second. So it means we are given the distance per second. How fast is its height on the wall? When we pull this ladder away from the wall, its height will gradually decrease. So we have to find the height on the wall decreasing when the foot of the ladder is 4 meter away from the wall. It means when there is a distance of 4 meter away from the wall, what is the height at that time? This is what we have to find. So here if you see Pythagoras theorem, we will apply. So in the Pythagoras theorem, let us say the x is a distance from the wall to the foot of the ladder, and the height at an instant time t is h, or we can say y, right? So applying Pythagoras theorem here, we will get perpendicular square plus base square is equals to hypotenuse square. So x square plus y square is equals to 25. Now what is given to us? Dx by dt is given to us. So this equation we will find its derivative with respect to time. So derivative, taking all the sides, derivative with respect to time, we get d by dt of 25 is equals to 2x dx by dt plus 2y dy by dt, right? And one thing we have given, when this ladder is pulled away from the wall, so dx by dt at an instant, is given to us as 2 centimeter per second, right? So 2 centimeter per second, or we can say 0.02 meters per second. Why we are converting it into meters? Because in the question itself it is given when x is 4 meter away from the wall, we have to find its height. So when the distance is 4 meter away from the wall, so we have to convert the distance into meters. That's why we have converted centimeters into meters. So now x is 4 centimeter, and what is y? From this equation you can find the y, that is equals to 3 centimeter, right? So now coming back again to this question, derivative of a constant term is 0, right? 2 into x, what is x here? 4, and dx by dt is 0.02 meter per second. Now 2y dy by dt, 2 into y is 3, we have find out from this equation, right? So 3 into dy by dt. After solving it, we will get dy by dt is equals to minus 0.16 upon 6 meter per second. This is the rate of decrease of height on the wall. As in this question you come across ki as x is moving away, the height of the ladder is decreasing. This is very important question. So till here you have to do it today, and in the next video I will be taking the questions from 11th onwards. Thank you all of you.